This is the specific heat lab, where we're going to be finding the specific heat of a couple samples of metal. To find the specific heat of these metals, we're going to be using the equation Q is equal to delta T times mass times specific heat. The specific heat is the amount of heat that it takes to heat 1 gram of a substance by 1 degree Celsius. To do this, we're going to use a simple calorimeter. It's going to be just an insulated coffee cup, and we're going to use some water. So we know the specific heat of water, and we can use the specific heat of water to figure out how much heat the water has absorbed. I'm going to take some room temperature water. I'm taking 80 milliliters, which is 80 grams of room temperature water, putting it into our calorimeter, and we'll find the initial temperature of this water. Okay, and while that's getting to the equilibrium, we'll take a look at these two samples of metal. So I have two samples of metal labeled A and B, and they're heating in a boiling hot water bath. So the initial temperature of these two pieces of metal is 100 degrees Celsius. They're in boiling water. They've been in there for 5 or 6 minutes, so they've reached equilibrium with the boiling water. So the initial temperature of the metal is 100 degrees Celsius. What I'll do in a second is take the metals out of the boiling water and place them into the calorimeter with the room temperature water. When that happens, the metals will give off heat to the water, so the water will get hotter. We know the initial temperature of the water now is 19.5 degrees Celsius. We will, in a few minutes, figure out what the final temperature of the water is and be able to figure out how much its temperature changed. We know the mass of the water is 80 grams because we put in 80 milliliters of water, and its density is 1 gram per milliliter. And we know the specific heat of water is 4.184 joules per gram degree Celsius. All right, so I'll grab some tongs. Earlier I weighed metal A, and it was 91.8 grams. So I'm going to take this sample of metal that's 91.8 grams. I'm going to take it over here and place it into our water, which has an initial temperature of 19.6. And you see right away the temperature is going up. Okay, we'll stir this around a little bit. We want to wait till it reaches an equilibrium, so wait till the temperature of the water is no longer increasing. Right now the metal is giving off energy to the water, and the water is absorbing that energy. We're in an insulated container, and we're going to assume that all the energy given off by the metal is absorbed by the water, and that none of it's escaping out of the container. So it looks like we're at about a maximum here. We got up to 33.7 degrees Celsius. 33.7 degrees Celsius was the maximum temperature of the water, and we can use that to figure out how much heat the water absorbed. When we know how much heat the water absorbed, it's going to be equal to the amount of heat released by the metal. And we'll use the same equation again. The heat released by the metal is equal to the heat released by the water, but with the opposite sign. We know the temperature change of the metal. The metal started at 100 degrees Celsius. Its final temperature was the same as that of the water. We know the mass of the metal. Metal A was 91.8 grams. I found its mass before I put it into the calorimeter. And we'll be able to solve for the specific heat of the metal. We'll try it with one other sample. So I have a similar calorimeter. We'll add 80 milliliters of room temperature water. We'll find the temperature of this water initially. So the initial temperature of this water looks like about 19.9 degrees Celsius. Sample B has been in the hot water bath for 5 or 6 minutes now. It's reached an equilibrium with the boiling water. So the initial temperature of sample B is 100 degrees Celsius. Sample B's mass is 268.5 grams. 268.5 grams. It's a more dense metal than sample A. Alright, so I'm going to repeat the procedure. I'll take metal B from the hot water bath. We have a 100-degree piece of metal right here. We're putting it into room temperature water, and we'll watch the temperature of the metal increase. The temperature of the water increase. We'll stir it around a bit. You see the temperature going up. So we can see already that this one's getting hotter than the first sample. So this metal must have contained more heat. It must have a higher specific heat than the first metal. And it looks like we're kind of leveling off here, so it looks like 37.5 was the maximum temperature reached by the water. So 37.5 was the final temperature of the water. It's also the final temperature of the metal. The water got hotter, the metal got colder, and you can use this information to calculate the specific heat of metal sample A and metal sample B.